revenue. If you have missing data, you can maybe replace the missing value with the average, or just remove it. Yeah. And then you also need to normalize or standardize the predictors, which are your independent variables, so that they can be treated equally. So if you don't want your predictors, some predictors that have high values, for example, age, and also your waist, your centimeter waist value to have different to be treated differently. So your age will be like 25, 30, whatnot, but then your waist size 70, 80. So what you want to do is you want them to be treated equally by normalizing it. Yes? So far so good?
Yeah.
And then also you want to have balanced data. This means that the classes of your observation have to be more or less equal. So for example, the number of observations, let's say you have cat, dogs, and fish. That's what you want to classify your observations, right? So you need to have balanced data by either oversampling, which means you're adding more of the minority class. So for example, if you had 5 fish and 100 dogs, you oversample by adding more fish so that you have balanced data. It does not have to be 50-50. It at least has to be some sort of it has to be at least representative of what the data should be. Or you can do undersampling, which means that you're removing some of the majority class. So with the previous example where you had 2 fish and 100 dogs, you're going to reduce the number of dogs in your data. And then we have a hybrid, which is a mixture of oversampling and undersampling. Oh, sorry. Yeah. So far so good? Any questions? Yes?
Must play now.
Everyone understand that? She was asking why we're putting the average that is data imputing, and that is so that we don't lose information. Because sometimes when you remove values, you lose information that might be important. Yes? We're not there yet. We're going to get great.
You want to put pressure now.
Any more questions? Great. So to explore and assess your data, you need to visualize the relationship between your predictors. So you need to understand how one predictor affects the other one. You can do this by using a matrix scatter plot or a correlation matrix, so you can understand what effect the other variable has on the other value. For example, there could be a relationship between height and age, right? So you want to understand, is it a positive, is it a negative relationship, so that you can later on go back when your model is active and be like, maybe it's because of the relationship between those two variables. Great. And then the other thing that you also need to do is fit your data so that you have a training set and a testing set. This could be 80 or 20, 75, 25, your choice. 70% or 30%. So you use your training data to train your model, and then you use your testing data to test the model. So you train only with the training, right? And then the testing is sort of to say, has my model, does my model now understand what it has been trained? Right. Yeah. So those are the four algorithms that we'll be going through. So we're going to start with the logistic regression, and then followed by the KNN, support vector machine, and then naive Bayes. And then in order to validate your results, we're going to use a confusion matrix. So a confusion matrix is a table that visualizes the performance of your classifier. So can everyone see the table on the slide? Okay, yeah, so. So the diagonal elements are the correct classification, and the off diagonals are the misclassification. So the higher the values on the diagonals, the better it means that your model is performing well. And then if that's not that great, then you need to go back and work on your model. So you have true positives. True positives, it means that on the side you have your actual class, which is what your data set is saying, and then on the top part you have the predicted class. So true positive means that what you've predicted and what's in the data set is the same. So it's a true positive. And then you have false negative, where it's supposed to be positive, but then your model says that it's false. Yeah. And then you have false positive. False positive means that in the data set it's false, but then your model says that it's true. And then true negative means that in the data set it's negative, but then your model says that it's true, right? And then from this matrix, you can then compute other metrics that you can then deliver to your client, or even explain better, because a confusion matrix just gives you a feeling of what the results are. So from the confusion matrix, you can calculate the classification accuracy. The classification accuracy is the sum of your diagonal, right? So it's your true positive plus your true negative, which means that what's predicted is equal to what's in the data, divided by the sum of the entire table. So which is your true positive plus your true negative plus your false positive plus your false negative. And then from that, you can also calculate the misclassification error. The misclassification error measures how bad your model performed. So which is 1 minus your accuracy. Yes? Everyone's still on the same page? Right. And then from there, you can then go in and calculate the sensitivity rate, which is your recall or your true positive rate. So this is the ability of your model to correctly classify positive outcomes. So it's the probability of you detecting something, which is true positive divided by true positive plus false negative. And then you have your specificity, which is your true negative rate. This is the ability of the model to classify your negative outcomes. So it's your true negatives divided by the true negatives plus the false positives. Yes? Okay. And then you also have precision. Precision measures how accurate the model is making positive outcome predictions. So this is divided by true positive divided by true positive plus false positive. And then you have false positive rate, which is
I think I don't feel comfortable.
I can't hear the first one. It's part of the native. What activation? Yeah. So you have your 10H, you have your sigmoid, you have your ReLU, you have lot. But then this is not. You can use it there, but then you know what I mean, right? Yeah. Okay, so now let's go to the notebooks. We're gonna run through the notebooks together, like through the entire process together. So the data that we're using is the.
So can you zoom in the notebooks?
Do I keep doing something wrong?
No, something wrong with that cable.
So, do you guys have your notebooks open because we'll be running everything together?
Mine just zooming in.
Zoom on.
Yeah, just to make it legible.
Glucose concentration, 2 hours in oral glucose tolerance. You have press, which is diastolic, blood pressure, skin, triceps, and so on and so on. And then our Y, which is the class, is the person diabetic or not, which is no or yes. Yes? Does everyone understand the data? So the data, like you're gonna call the data from GitHub, which is a GitHub supply data. And then when you have header, you have it like this. This is a summary of your data. Albert, does everyone know how to code?
Good question.
Let me know. Does anyone have problems with Python? Does everyone understand Python? If you don't, can you please raise your hand so I know? So it's a yes. So you understand the basics. Fine, so data.head gives you a summary of your data. Not summary, but then it gives you like the first 5 rows of your data. So the data looks like that. So the question, do patients show signs of diabetes according to the World Health Organization criteria? Yes or no? So what you do now in the gathering and preparing section, you want to describe your data. Describing your data means having a summary of your data. Understand the mean, max, average, and all of that of each of the independent variables. That's what describe does. And then you also want to count the number of classes that are within your data. So describe gives you an output like this, where it gives you the count, it gives you the mean, gives you the standard deviation, it gives you the minimum, it gives you the 25 percentile to the 75 percentile quantile, and then it gives you the max value. So this gives you an understanding of what each of your variables look like, right? So on top there are variables. So this is the pregnancy variable, how many times a person was pregnant. So on average, it was about 3 times. And this is standard deviation, and so on and so on. And then the number of classes, you have 500, 0, which means 500 are no, and 268 are yeses. And then you visualize them with a bob plot. And this is what it looks like, right? And then you also need to look at the data types. The data types allows you to understand is your variables numerical, categorical, and so on. So use the use the method dtypes to get your types of data that you have, data types that your variables have. So you also need to, in order to find your, am I moving too fast or everyone's good? Okay, so in order to find out if your data has any missing values, you can use this line which says is NA, which means are there any missing values, dot sum. So if there were missing values, there would have been a number greater than 1, greater than 0, I mean. So the data does not have any missing values. And then now we want to standardize our data. So first we're gonna take out the predictors, which are your independent variables, and then also take out the response variables on the side, and then you standardize your variables. So the sklearn has it has a standardizing function that you can just use, and this is how it is. So remember, initially when we described the data, it had big numbers, right? Now, as you can see, it's more standardized, like 0 point something, so it's within a certain range. And then remember, our data was imbalanced. We had 500 no's and 268 yeses. So in order to make them balance, we can then, I chose, this was a personal decision, there's no rule of thumb or anything. I chose to, undersample, which means that I took a minimum. I took 250 from the 500, right, from the majority class. So you first have to use random.seed, because you want to randomly select 250 observations. So you don't select a portion of the data which might cause some sort of problems later on. So this allows you to select 250 zeros. Also selected another 250 values from the 268. I have 250, 250. That was a personal choice. You could have done it differently, or you could have kept it at 268. I like 250, and I chose 250. Yes? Right. So now you have balanced data, and then, sorry. Okay, so now you will have balanced data, then when you plot it, there will be balanced values. Is everyone following? Great. Remember how I said that you need to understand the relationship between your predictor, right? This can be done by using a correlation matrix or a scatter plot matrix where you visualize your data. So this is a correlation table where you have your variables, your predictor variables on the sides. So you get a value of 1, which means that they're strongly correlated, but then the diagonals are supposed to be 1 because it's the same variable, so it's going to be 1. But then so correlation lies between -1 and 1. So when it's from 0 upwards to 1, it means that you have a positive relationship, and then when it goes to, let's say, 0.5, you can say it's a strong correlation, and it's the same with the negative side. Yes? Right. So you can also nicely visualize your correlation table by using colors to help you pick up the strong relationships. So on the side there's a gradient that can help inform you, and yeah. So this is what a correlation scatter plot, matrix correlation scatter plot looks like, where you basically plot multiple scatter plots of one variable against the other. So it's the same thing. Instead of having a value, now you have a visual of what the relationship is. Also, what I also did is that I colored different lists of observations. You can try it to test it out. Does it make sense? Yes? Okay. So always put a random state so that you can always manufacture the same results. Otherwise, you're going to be so confused why you're getting different results every time you run it. So, and then we move on to the validate, right? So I created a validate function because I felt like it. So, but then there are packages online, sklearn packages that you can just use. But then I prefer it this way because it was easier to sort of explain how to do things. So this validate function, it takes in the y-test from your data that you've split into training and testing, and also the predictions that you've made. And then it uses the confusion matrix function from sklearn to to output a matrix of confusion matrix, and then from there I have my true negative, false positive, false negative, and true positive. So that allows me to calculate any metric that I want, because those are the four values that I want, right? So from there I can calculate my accuracy rate using the formulas that I had on the slides, where you had the accuracy rate is your true positive plus your true negative divided by the sum of your entire confusion matrix, right? And then you can also calculate the sensitivity rate, specificity rate, precision, false positive rate, and also the miss rate, right? So in Scaling, does everyone have access to the internet? Okay. Can you guys go to the Scaling document file? You write Scaling on Google, and then you go to documentation. Okay, you're gonna need this. So when you're working with a logistic regression, you have to first instantiate your model. That is, tell Python that you're about to use a logistic regression, set your parameters, and then this can be found by just typing logistic regression, and then it will tell you what parameters you can set, what are the default settings, so that you know, right? So you come here. So to instantiate your model, you have the logistic regression, and it has a penalty of L2, and then it describes what each argument is and how and why you should leave it as default or none of that. So I just chose to use default values instead of changing stuff, so they can be simple. And then after you instantiate your model, you're going to train your model. So you have your X using your training set. So you have your X train using your training set. So you have your X train and your Y train. So you use the fit model. So you instantiate your model, and you called it log reg model. And then you train your model by saying the name of the variable that you instantiate the model to, dot fit. And then you put in your X train and your Y train. If you go back to the document, you go downwards, but it'll tell you fit the model according to the given training set, and those are the functions that you can call to work with your model that you've instantiated. Is everyone following? Okay. So, and then to make predictions, right, you're gonna use the dot predict function. So you make predictions on your training set using only the independent variables. So if you go back to the document, there's a predict function. It's a predict class label for samples in X. Yes? Great. And then if you run that, it's not gonna output anything because you basically give it instantiated and also creating variables. But then now, this log reg will give you an array of values. So it would have done the whole it would have used the decision rule to classify the variables. You don't have to do anything additional. So it will tell you 0, 1. So if you want to print it out, you can print it out, and it will give you value 0, 1, 0, 1. And then you can validate using the function. Remember, I created a function. So this is what the confusion matrix looks like. So you have 45 true positive, and all of that. And then you have an accuracy of 0.74, a sensitivity rate of 0.67, specificity rate of 0.8, precision of 0.76, false rate of 0.196, and miss rate of 3 to 9. So you can do all of that. You can either use my function. So my function was just for the purpose I can explain. Or you can use a built-in function. So sklearn has a a score function where it gives you the accuracy rate, and it's called dot score. So the name of the model that you've trained, dot score, and then you put in the testing data. Yes. Okay. So now, is everyone good? So now I'm gonna give each group 2 minutes to discuss the data. And then I want like some sort of output from you. Like explain how well the model is performing, because you want to be able to communicate this to your clients. So your client is WHO, which is World Health Organization. You have 2 minutes. Just talk among your groups and understand what the accuracy rate is telling you, and from the accuracy rate, what does the confusion matrix is confusion matrix is telling you, and all of that. 2 minutes. So that is like 53. 10, right? Is 10:51. I want something. 10:53.
Oh, but I gave you the paper, ne? Okay, let me just forward the email to you. Sorry.
You can use the
Huh? I know I have your email address.
That first three is offline.
Yeah? What? Yeah, like connected, disconnected once in a while. So I have to be sitting here making sure that.
I don't have energy to get on board.
Wrong shoes. Any issues?
Okay, so everyone's done. Let's go back. Let's go back to the slides now. So I'm gonna randomly pick on people, well, a group, and then I want you to interpret what the metric is saying. Are you listening? I'm gonna randomly pick on a group. There's like 6 metrics, and I'm gonna randomly pick on a group to tell me or explain to me what the metric is saying about the model, performance of the model. What does Are you guys listening to him? He's quite dark. Are you listening to what he's saying? He's trying to interpret what the precision and measure is saying to us. Do you guys agree? Does someone else have like a different answer? Can you please be louder?
76% of the time, the model will correctly predict the positive
Does anyone have a different answer? Okay. Yeah, what you just said? Saying the false positives are very low, which is a good indicator because is that right? Does someone have a different answer? Yes.
What's the ranges of the like is like 80% for specificity? Is that actually high? And is the false positive is 20% actually low? So more or less like what?
So you would want your miss rate and your false rate to be low.
Yeah.
You want your specificity and sensitivity to be high.
But what is like is it high like 99% actually or is it like 52%?
High is intuitive high.
Okay.
I'll think if look from your judgment, looking at the data, you'd say like a seven, like usually people reference the accuracy rate to the results from the previous study that we had and what they found. But then right now you can say 70% is high, 80% is high.
Okay.
Your high is your high. Okay. The accuracy rate, close to accuracy rate.
Accuracy rate is high, it's good. We thought that we would need some improvement on confusion matrix by adding and maybe if you manipulate pair under the attributes that you're given on the data, that could also improve the accuracy.
Do you guys agree with me? You can't hear. Can you please be louder? Project your voice. Use your bass.
The accuracy rate is good, but then it needs more improvement.
Please quiet down. Yeah.
The rate is good, but it needs more improvement. So maybe it could improve the confusion matrix by adding more data and by playing around with the attributes.
Do you guys agree? You can't hear? Okay, maybe you should be real. Stand up when you give an answer.
Come on, man.
Don't be shy.
Accuracy rate is relatively good, but it will probably need more improvement, say by adding more data or playing around with the attributes. That might increase the accuracy.
Did everyone hear him? And do you guys agree? Can I have nods? Yes, we agree. Smiles. Okay, cool. Okay, let's move on. We're going to K nearest neighbors. Right? We're going back to the slides now. We're gonna give people like 10 seconds to settle in. Okay, good. KNN, which stands for K nearest neighbors, is a non-parametric and instance-based learning algorithm. Non-parametric means that it does not make any assumptions on the underlying data, data distribution, and it's instance-based. That is, it does not explicitly learn a model, which we call it, which means that it's a lazy learner, and it does it by memorizing the training instances, which are subsequently used as knowledge of the prediction phase. Does it make sense? Okay. So in KNN, an observation is classified by a majority vote of its neighbors. That's why it's called K nearest neighbors. With the object being assigned to the most common among its K nearest neighbors. Yes? So you are basically assigned to a class based on who's surrounding you. Saying that you are an observation and people around your observations. So there are disadvantages and advantages of KNN. The advantages of KNN is that it does not make any assumptions of the data. So you give it data, it does not make any distribution assumptions, and it's also easy to implement, explain, understand, and also integrate. The disadvantage of KNN is that it's computationally expensive. It requires a lot of memory, and for large data set, the prediction state might be slow because it's instance-based. That it memorizes everything and then it predicts. So it will be the same question using the data science flow process, and then this is what the model looks like. So as I mentioned, a KNN is a lazy learner, so it has no explicit training phase. So you pass it, starting from the top, you pass it training set, where your Y, which is your response value, is your does the patient show signs of diabetes, right? Which is 0, 1, yes or no. And you also have your independent variables. So what happens is that you simultaneously pass data through a KNN classifier, and then it goes back into memory when you pass it the test set to classify values. Does it make sense? And then based on the surrounding neighbors, it classifies an observation, the majority vote class. Yes? Majority vote is, actually I'll show it to you. That's it. Yes, sir. K means is clustered. This is classification. K means unsupervised. This is supervised. K means you use a centroid that continuously changes, and then observations gets assigned to the group. This one, we have an observation, nothing changes. The only thing that changes is the number of surrounding observations based on the K that you set. Okay, so stage 1 in KNN, K nearest neighbors. You choose your K. K is the number of neighbors that you want to consider, right, in order to do your majority voting, right? So I chose 6 as an example, and my response is the color. So we have green, and blue, green and blue observations, where the star is our unknown response that we want to predict. Yes? Any questions from that? Yes?
How do you choose it?
At first you choose it, just choose one, and then if your results aren't impressive, choose another one, and then you do cross-validation, which will be covered later. So for now, it's just like a starting your ignition, you're just filling things. So you can choose any value you want, and then you can go back and change. That's why, remember like how the data process, like it's sort of repeated as a circle? It allows you to keep on changing your K with however you feel. So you can even choose 25 based on, sometimes when you start, you need to use logic based on the number of observations. Which one would be more suited? Which K value would be suited? So if your data set is small, you can't choose 25 because it's like you're choosing the entire sample, right? Yeah. Does everyone understand this plot? Your star is what you want to predict. It's unknown. You don't know the class. And then the surrounding dots, those are the observations, and the classes are known. Okay. So you've chosen your class, and then the next you calculate the distance, which is you can calculate Manhattan, Malahabonis, all of those fancy distance, whatnot. But then we're going to use Euclidean. Also, in the sklearn, it allows you to select which distance function you'd like to use. Right? And I think the default, it could be Euclid or Manhattan, I forgot. So, you calculate the distance, yes?
So what are the classes there? Is it the green?
So you have green and purple classes.
Those are the two classes.
Yeah.
And so you want to know which class does the orange one belong to?
Is it orange?
What is
Yes.
it? Red.
On my screen it's red.
Yeah. Okay. Cool.
Yeah.
You want to know if it belongs to the green or to the purple.
Yes.
Okay. Cool.
Does everyone get that? So now you calculate the distance from that one observation with the other observations. But remember, you chose 6 classes, right? So step 2, you select your K nearest neighbors. So based on the calculated distance, which observations are closest to the observation that you want to predict, right? So I've just created a circle, and these are the 6 K nearest neighbors for that observation, right? And then looking at that, you can see that there's 4 purple and 2 green. So majority class will be yes. So purple has 4 classes, green has 2 votes. So your unknown will be, your unknown class, which is red, will be purple. Yes? Any questions? Okay. No questions? Oh, sorry.
Questions?
You guys got your data yet?
You just gave us like one match video.
Okay.
You give us the video and then the spreadsheet that labels the specific event.
Alright, and where are you storing that data?
So far it's just on a spreadsheet. We're probably gonna have to move it to a database, but we're still stuck with knowing what we're gonna do with it, like even at first, because then like we can't. Well, we have to search if there's something that can. Well, you know how image like machine learning you use like images or something. So now our events are like 10 seconds long. So now we need a video and you can't cut them down into specific frames.
Do you not understand why it's
So we don't know.
instance-based and
It's
it's
just
called
gonna
a laser? It's because it does not do anything, it does not train on model specifically. It looks at what's around it and then it classifies based on majority group. And it does it for each and every new observation from the test set. That's why it's instance-based and it's lazy. So it uses things in memory based on how observations are situated. Great. So now let's go to the notebook. Any questions before we go to the notebook? Okay, let's go back to the notebook. So something that you'll notice when you're training models, different types of models, is that you're gonna basically have three basic lines. You're gonna instantiate the specific model that you want to instantiate. You're gonna fit it, which means that you're training it, and you're gonna do your predictions. Those are the three basic lines that you'll always be doing. So since we're doing k-nearest neighbors, you can go back to your document. If you don't know the function, right, and type k-nearest neighbors with KNN, and then it will give you a list, and then you want to classify it, right, a KNN classifier, and then you select that, and then it will give you information and the arguments that are found in the model. So yeah, the first thing that you'll see is add neighbors. Add neighbors is your K that you want to set, right? And I set it to 6. So you can set it to 10, 5, but then try to, I think, if you make it, sometimes if you make it even, the problem is that you might have even observations, even classes, but then if we have an odd number, like 7, there will be like 3, 4, kind of thing. Make sense? So you won't have a problem like he gave, where you have 3 green and 3 purple. Yeah. So now we're gonna instantiate the model using the k-nearest neighbors classifier function from sklearn, and we're gonna set the k to 6, which is the n neighbors, and then we're gonna fit the model using the training set. So you have x train and y train and your arguments, and then you're gonna make the predictions as we've done before using the dot prediction function. So you predict using your x test. Questions? Questions? Okay, cool. And then we're gonna run our results through the validate function, where you have your y test and the predicted y values from the KNN. So you have your confusion matrix and your results, right? So you have an accuracy rate of 0.69 and other metrics. Any questions? Yes?
But you said that that's the alcohol stop there. Alcohol stops for you. So you take that money every month and then you get your bill in December. But it saves you from overspending in December. Some of us already buy a lot of bills now in December. What? But these December specials are live.
How do you get 100%?
Oh, that's the day. A cousin of mine, but she gets the small. Small. People blog stuff and they still do the stuff from the people they blog. When you get properly bored, you're going through But did they say his number?
Yeah, I almost have because I think I have.
Bali's posted his blog.
It's gonna die soon.
Yeah. Oh, when you saved this one number because you're the master.
Any more questions?
You haven't heard the new ones.
I couldn't know you, ma'am.
Let's go back to the slides. Oh, and then there's also a dot score. Hello. Hello. So there's also a dot score function that you can use in sklearn that will give you the accuracy rate of 0.69. So now we're gonna go back to the slides. So now we're moving on to support vector machines. Which is SVM for short. Okay, so I'm gonna start. So support vector machines are supervised learning models for both classification and regression problems.
How many more algorithms?
Sorry?
How many more? You have 2 more.
Yeah, there's naive Bayes.
Okay, so this one and naive figure the last one. You take like a 5-minute.
Oh, 5-minute break.
Yeah.
Is everyone tired?
Yes. 10 minutes break.
Okay, I think maybe Mike needs to rest because this is gonna be a bit too much for some people. I'm gonna see. We can resume at 11:30. 10 minutes break. Is that okay? 10 minutes.
Everyone is looking so to me. What's it?
Cool. You're gonna be famous. Yeah, but you keep going there. No, that puts you. Clear.
Everyone was angry.
Yeah. That's good. Then I saw on Twitter or something. I knew that this thing wasn't charging. Can't remember. I don't know, but I don't have my plan. Level, I didn't want to do. So yeah, but I think first case is going to come up.
She wants ugly Adele. Ugly Adele.
She wants others. Yes, later.
The Babalas comes immediately after you eat. Not pasta.
Pasta, that's staying good. Pasta. I'm not from the thing. Eat pasta.
What is it? What?
Not GABA.
When her pub cake is very sweet. So look at what the You come alive earlier. Because it just came alive. Just had a shine.
If you go on live, what are you doing?
I'm combining video rock with fashion.
You combining what's that?
Video rock.
Video rock.
You know.
I think they're charging because hopes yeah, Africa. Yeah.
Wow. Thank you. What? Guys, if when you eat,
What will be done?
Really, you know, when you give one person a chance to like lotion on your side,
She's the experience when it comes to shine.
whether you combine and most Ghanaians shine on the
No wonder shine like a sun.
Oh, it can't be nice.
You see the
You feel proud, you can say that. You can feel it. How do you feel? There's no. I really can't. There's no time. I'm calling I'm calling. Oh, how do you?
Yeah.
Different things for everything.
As much as there's a different for everything.
Oi.
There's different for everything. So you have to understand. That's just one, but the way you say it is just so.
Yo, you guys honestly get people's answers. No. I'm seeing it's my home screen now. It's fucked up.
No.
Okay, it works sometimes. No, you get this thing on the
You
Korean
have to
settings.
compete. You have to compete.
It works sometimes it doesn't. Yeah, it's movable. You move it wherever you want it to be.
Is everyone well rested? Can we start? So now we're going to be going through support vector machines. Support vector machines, or SVMs, are supervised learning models for classification and regression problems. But then we're going to be focusing on the classification side of it. This requires everyone's eyes. Can I have everyone's eyes on the screen and not on me? So, from your view, which hyperplane or line separator best splits the data points? So you have orange, red, and green. If you think it's orange, can you please raise one finger? And then if it's red, 2 fingers. Green, 3 fingers. Raise them high.
What's the question?
Which hyperplane line best splits the data? So you have orange, red, green. Orange, please raise 1 finger. Red, 2 fingers. Green, 3 fingers. Raise
Is
them
it
high.
best fits or best splits?
Best splits. Slices, dices.
So which finger for which color?
Orange, 1. Red, 2 fingers. Green, 3 fingers.
I was going 3 because it counts all of them.
Sorry.
Who's colorblind?
Tambela.
Tambela.
It's
Guys,
between orange and...
raise your hands.
Well, we'll take the red because...
Yeah, but which one is it?
Okay, it seems like there's a lot of 3s in there.
Stay confused.
And then there's like 2. No, this side there's a lot of 3s and then there's some 3s and there's more 2s. But you already saw the answer. This is not correct.
Gave us this one.
So the best one is green. But then why? Why did you guys choose 3? Someone who had a 3 up? Why is it a 3?
No, I just looked at the concentration of the points, how they were presented.
Yeah.
The blue ones were more to the left.
Can be your color, pink.
Yeah,
Red.
and then they were more to the
Do you guys agree with him? Why was it
Hello,
green
we must
instead of red or orange? Even with the other ones. Orange is red. Why green? Okay.
Go back. Go back. What was the question again? I agree.
Why green? Why the green line and not the red or orange?
Can someone please answer that? And we can't have the same people talking.
I think it's because
That way you're exempted from talking.
But it's an opinion.
What's your opinion?
Isn't it because they're like it has the most points closest to it? That's right.
Most points closest to
To
the
the
green.
line, to the splitting line, and that's why it's the correct one.
What? Yeah.
Closer to the density,
Better English.
Okay. Any? That's 1, 2. Yes.
I think green also accommodates the distribution.
You guys are saying the same thing.
Yeah, I think some people. Cecil can answer this one. Why is it not the orange?
Grapes.
Why not orange?
Cecil is that guy.
Why? Why is it green?
So much
Is this on the rubbish?
Another one is
Bonds. Yeah,
there's your Vito there. He can also answer.
Yeah, Vito can answer.
No. What's your answer?
Chose the second one. Why you chose the second one?
Why the second one?
Getting interesting answers here. Look nice. What did Cecil say? He said what? Started on the Y-axis. It looks nice. Yes, it's you, man.
I chose the green one.
Chose the green one. Why the green one?
Because the concentration of the splits correctly.
It splits correctly the concentration. Okay. It means you can't concentrate. Alright, let's see who else. Yes. No, not you, that guy. You like green. Actually, what he said is scientific. Yeah. People tend to go for the color that most soothes them, you know? It's the same logic when you're cutting wires that explode. You go for the wire that kind of looks nice.
We never cut the red one.
Right. So that's fair, we understand that. Why not the other lines? Let's see, yeah,
I chose the orange one first.
I chose green because
It splits it perfectly.
yeah.
Nice. That's it. It just splits it perfectly. Like concentration to the y-axis and to the what. We don't need all of that stuff. It just splits it nicely.
But orange splits it the best.
Yeah, but it touches the other ones.
Yeah,
Why doesn't anyone say the orange one touches so many lines, so many dots?
that touching is
But the red doesn't
What's
touch
your
also.
answer?
I think it separates the maximum margin.
I wonder you're reading my comments. No, I'm kidding.
Now you'll read on the next slide.
No, I'm kidding. That's right.
Okay, but then somebody said something else. Ne? Somebody said the red one also doesn't touch some dots. So then now you use a different criteria. Now you exactly the distance. Now you're looking at, since the green one and the red one, they both don't touch any dots. Now you're looking at which one is the furthest. Which one is the furthest from all of the dots. Right? That's your next criteria. And then you get your answer for the next slide.
but that's debatable.
It's
Yes.
debatable.
Yeah. It's so far from the pink ones.
It's so far from the pink dots.
Yeah. And the green one is closer to the pink dot.
Yeah, maybe from your perspective, you're only looking at that one, but you're looking at distance of every
But
point.
then can you see that the green one also has points here?
So the correct one is the green one. Do you want the one with the most close to the
No, which one best splits the data?
and I had distance. I had the points afar. I had someone say that.
Yeah, yeah,
Like
yeah.
they were
Points apart.
Oh, short distance. Oh, okay. No, I agree with the short distance one.
Okay, cool, guys. Right? Yes, you can proceed.
That was interesting.
So the criteria that you're looking at is you're looking at the line or the plane that maximizes the margin of the hyperplane. So the margin is the distance between the hyperplane and the few closest points, right? So, and also the points that lie on the margin are called the support vectors. So your hyperplane that you choose is the one that maximizes the support vectors that lie on your margin. Yes? Does it make sense? That's how the SBA works. Split the data and then it chooses a line that maximizes the margin where your support vectors lie. Support vectors are data points that lie on the margin. Yes?
I think now I'm a bit confused by the term maximizes.
Maximize as in, can you see the line?
Yeah.
Can you see where the next data point is? The distance from.
So it needs.
Sorry?
That looks like. Okay, but anyway.
It's the green line.
Oh, but that's
It's the
the
orientation.
red line, right?
Oh, it's changed orientation.
No, it's because of the image, the way it looks.
Oh, I see.
Sorry.
That's the confusion.
Is it the red line?
It feels like the red line.
Don't link this picture. Wait.
Because
Don't link this one to all of the previous slides.
Still feel like the red line, but anyway. The term maximizes. I think
So when you're
Yeah, and then you look
maximizing the
there.
margin, right? You have that line, right? From that line that you have, there are points next to that line. The distance from that line to those points, which are support vectors, that's the margin.
So it has to be the furthest away.
Yes, you're trying to maximize it.
So doesn't that contradict our density thing that we kept on saying for the previous one? Because more dense, like the ones that are closest.
What do you mean by that?
Go back to the previous slide, please. We said it's the green one because there is a lot of points, those
Yeah.
pink points that are close to
Oh,
the...
no, I did not say that.
But we said that and you
Yeah.
agreed with us.
No, I did
that's
not.
what I meant.
I said
Huh.
they were right. I didn't say you were right.
People are saying
But we said
concentration,
we're all saying the
density.
same
Yeah, I
thing.
said you're all saying the same thing in different
Oh, we're all
ways.
wrong.
Yes.
Oh.
I'm sorry, you wanted me to say you're wrong.
Yes!
Oh, you're wrong.
I felt
I'm sorry.
right. Like I thought I gave the right answer.
No, I just wanted you to tell yourself that you're wrong.
But still doesn't explain why it's not red. But anyway.
So now you're looking at the margin, right? So you're trying to maximize it. So you plot like a lot of lines, and then the one that maximizes that margin is the perfect line that you're going to use. It's the line that you're going to use as your separator. Does it make sense? Imagine a plane. Can I draw?
The explanation makes sense. It's just referring to the green line.
Stop focusing on the slides. Focus on the.
I think it's on the
Okay,
chip.
yeah, the explanation makes sense.
Does it make sense?
Yes, thank you.
Red is bad. The images are not linked to each other. So that's the green line.
That's just a new. Let's just assume
Let's
something.
move on. Great. Questions? Questions. Alright. So SVM can be used to solve linear and non-linear problems. So a linear problem is when your data can be linear separable, where you can plot a line and split the data, and then non-linear problem is when it's not linear separable, like you need to have like some sort of polygon or some sort of shape to split the data set. Make sense?
Yeah, just a comment on this. There's somebody who once said, oh, is your data linear or non-linear, if anyone remembers. So the cool thing with such things is that you don't have to worry too much as to whether you're dealing with linear or non-linear data. I've got non-linear stuff, and so therefore I have to linearize everything. Support vector machines is not one of those. There's nothing you have to linearize. If you're dealing with non-linear data, there are all sorts of hyperplanes that you can plot. There are all sorts of lines that can divide your data nicely. Okay? So maybe, so in that example, it's divided by a circle, in that example by a straight line, sometimes by a sine-looking wave, sometimes by multiple circles or whatever. Okay? Cool.
Great. So when you're dealing with a nonlinear problem, you can use a kernel. You can introduce a kernel to transform the original input to a high-dimensional feature space where your data can be potentially linearly separable. The reason why your data is not linearly separable is because in whatever dimension that you're looking at, it's not. But then from a very exponential dimension, from a very high dimension, it can be split linearly. So when you look at this image, right, you see like the first one, it's a circle. It's in a two-dimensional space. But when you now go into another dimension, when you introduce the kernel, it allows you to look at it from a different, like a 3D kind of vibe way. So now you can insert some sort of plane to separate the data points. Yes? And then what happens now when you now go back to the original, you can see that when you insert that linear plane, you have a circle around the original data set. Yes? Make sense? So there are different types of kernels that you can use. The popular ones, you have a linear kernel, you can have a polynomial kernel, you can have a radial kernel, you can have other kernels. You can also choose those kernels on the sklearn. You know how there are arguments, you can choose which kernel you want to use. and you don't know which one to use until you try it out and have results, and then see which one best splits your data. Yeah. So there are advantages and disadvantages of SVM. So the advantages of SVM is that it's a robust model. It's effective in high dimensional spaces, and it is memory efficient because it uses the training in the decision. And then a disadvantage of SVM is that it's computationally expensive and tends to be slower than other methods. Questions? Yes.
No, I understood what she said. There was no way I we're playing with injured players. No, but I played I was in the best team. Like we were playing for fun, they were playing to win. I was enjoying myself.
Towards the end of the second match, I just didn't play. I was just playing.
No, we punished them too much in this match. Like, whoa. Am I good? What's the good person? I was going today. It was cold. Yeah. No, it's not. No, well, there's people from all six are all coming and playing. They haven't played before. All of them. Because you guys don't talk before. So, I don't know why they brought us this chairs this time. This chairs are comfortable. This is not comfortable. I'll be feeling sad when I write my friend like proper Let me try something. Change this to. What else is it? Try linear. Try linear. It's the, for the SVM, the linear one, when you choose your kernel, is it linear straight? You write linear or len or something.
Yeah, the syntax doesn't.
Let's try running it like that. Or actually it does change. This no accuracy changed like to 75 now.
Or is it? What was it before?
74.
With what kernel was it?
No, 40. But it didn't change. No, but it did change. So the good set, just went to 7.5. So what was that? Just check this. Kernel.
Questions? Okay. So support vector machines can be hard margin or soft margin. Hard margin is when your data is linearly separable, and this is what the model is. So you have your training data, and it gets passed to SVM machine model, SVM model, and then above, that's what it does. That you're trying to minimize the margin from that using that cost function over there, given those constraints, right? You don't have to know those formulas to know SVM. So, and then afterwards you're gonna have after you've minimized that, you're gonna get a classification plane. The classification plane will allow you to then perform the classification of your new observations. So now when you now have your classification plane, you can pass it your testing data, and then from there you'll then use a decision rule where if the output of your classification plane given your test set is greater than 1, then it's a yes, and if it's less than -1, it's a no, and that's how you do your classification. Yes. Yeah. Can you use a sign? What is? That's your bias that you're adding. Any questions? He was asking what B was, and that's the bias. Okay. And then the next other thing is soft margin, which is when you're not dealing with non-linearly separable data, where you're not introduce a kernel, and also take into account that there might be violations within your margin. Violation means that your support vectors are no longer going to lie on the margin, but then they're going to lie within it. So you have to measure. You're going to be measuring the number. First, you're going to give your model tuning parameters. This include the slack variable, which is your penalty for misclassification. So you're giving it allows to misclassify, and also a C. C is like your cost value. So you determine the misclassification that's allowed, which is the same as a penalty, but in different value. And then a large C means that your margin is wide, and then a small c means that you have a narrow margin, that you're being strict with the allowed classification. Yes? So if you look at your classification plane, right, it has a K. The K is the kernel that you've introduced to do the whole transformation from one dimension space to another, to allow you to insert a hyperplane to split your data. Questions? Yes. Okay, so hard margin, that's when your data can be split. You take a line, you can plot it, and you don't need to introduce a kernel in any dimension. You can see that this data can be split using some sort of linear line, right? And then soft margin is where now you have to introduce some sort of weird shapes, circles, or even multiple circles like Albert mentioned, or even like some sort of polygon that goes around the whole data set. Yes? Yes?
What is it? The expression function.
So no, it's for that observation. Remember, let's say there's n observations. So you have yn, t, x, m, which is the one of the support vectors, and plus b. So for n is equal to 1 to capital N. So for each observation, you're gonna be using that constraint. So each observation will have its own constraint. Question? Right. So SVM is defined to work for k equal to 2 classes, but then when there are more than 2 classes, you can use one versus all, which is over. And this entails using fitting multiple SVM on one class and then compare it to the rest of the class and use that entire class as one class. And then from there have a real value confidence, then compute a real value confidence score for that fitted model. And then you classify the new data set based where you have the largest score. So it looks like this. So let's say your data looks like this. You have 3 classes. You have triangles, axes, and squares, right? So what you do first, let's start with this one on top. So you have triangles. Triangles are your positive class, and that's one class. And then you're going to convert the rest of the classes into one single class. And then you're going to compute f hat, which is the confidence score which is the probability score of that fitted model. Yes? And then you do the same for the other classes, where now the second class is the square. So you're going to convert the triangle and the axis into a single class, and then the squares will be another class. So your square in this case will be a positive class, and the rest of the class will be a negative class, and then you compute the f hat score, and then you do the same with the other one. And then and then in order to classify new observations, you plug in the new observation, and then the one that gives you the largest f belongs to the positive class where the largest f belongs to. Does that make sense? Yes? Questions? And then there's also 1 versus 1, where you fit k choose 2 pairwise classifiers, and then classify each with data point with using majority vote. Okay, so now let's go to the Jupyter notebook. We're almost done, guys. So in order to instantiate an SVM, let's go to the document and just type SVM. That one, the classifier one. And then you see it has arguments. So you have the C, which is your allowance of penalty that you want to have, and this can be a value from 0 to an infinite number. And then you have the kernel, the type of kernel that you want to use. So remember I said that you can use linear, you can use polynomial, you can use radial. So, and each based on whatever kernel that you use, that there are corresponding parameters that you also need to set. But then some of them have been set by default. So with the linear one, okay, going back to what I did, I chose a polynomial distribution because I felt like it. Sorry? It doesn't have to be, I just felt like writing polynomial. And then I chose polynomial, and then with degree is equal to 3. in order to determine if it's the best or not the best, it's based on the data. So you have to try different kernels and then see which one. So the polynomial kernel has the degrees argument, so, and then the one has the gamma, and yeah. So now you instantiate your model like we've done previously using svm.svc, and then you fit that model using your training data, and then you make the predictions using the test set. Everyone's on the same page? Great. And then you pass through your, the results through the validate function, and then you get your confusion matrix and your results. So you get an accuracy rate of 0.74, yes.
What's going to happen if you change that poly to linear?
You're going to get different results, performance results. So you can come here. It takes a while to...
To run, okay. Cool. It's one.
Yeah, I have other things running on mine.
Okay. Also, it will change the accuracy.
Yeah, like the results will change.
Yeah, okay. Cool.
Yes. Okay, so now let's go to naive Bayes. Does anyone have any questions with SVMs? Okay.
Can you go up back to that SVM code from where it starts? Yeah. Okay. Okay, guys, just a note here. Just look at how short all of that code is. That's 4 lines of code. That's all of machine learning there. Okay. Yeah, well, there's the validate and all of that. Okay, but that's essentially it. So that meme that we had on Monday wasn't lying. Okay, that what my friends think I do, what my parents think I do, and what you really do is from sklearn import SVM, SVM model.fit, xtrain, ytrain, done. That's it. That's machine. That's all of machine. Everything before this was data analytics stuff that we did in phase 1. Everything, even the validation stage, because you're just doing formulas there. Okay, so that's it. That's why she keeps opening the documentation, because that's essentially the function that does the machine learning. Okay. Yes. So now you're machine learning experts. Next time somebody scares you and say, I do deep learning and machine learning, or you say, oh, you write 3 lines of code. Okay. Cool.
So we're gonna go to naive Bayes, which is the last model for the day. You guys don't sound excited. Now you know like 3 classification
When you output, you need to say, okay, this is a dog. Let's say you get a dog. And then now you want to generate an output saying, here's an image part. It's going to say, this is a dog. And saying percentage of
naive Bayes. So quiet down. Naive Bayes is a classification technique based on the Bayesian theorem with the assumption of independence among predictors. Who has a stats background? Stats background? So you guys probably know this, right? So Bayes theorem. So the Bayes theorem is given as follows. So it's the probability of event A given event B.
Sorry guys, some of you are single, some of you have Bayes. There's Bayes theorem there. Please pay attention if you have a Bayes.
Then what happens to the single?
The single ones, I don't know.
Apply this theorem to get a bay.
Okay, so like this is the Bayes theorem. Write down please. So where you have the probability of event A given event B, which is equal to the probability of event B given A times probability event A divided by probability of event B. And yeah, that's the Bayes theorem, right? And essentially, in the context of classification, the base theorem is used as follows, where the probability of class A, of class I, given your predictors, is equal to the probability of X, which is your predictors, given the fact that given class I times the probability of class I divided by the probability of X, right? So where your class I is the ith class, X is the set of n predictors, so your x1, x2, x3 to n, and then probability of class I is the probability of class I given the x predictors, given that x happens and all of that, and the probability of x is the probability of x, and the probability of class I is the probability of class I. Yes. So probability of x is a normalization term which we can do away with by introducing a proportionality sign. So instead of dividing by probability of x, since it's a normalization term, you can say probability of class I given x is proportional to probability of x given class I times probability of class I. The reason is that since it's a normalization function, and we know what the values of probability of x given class I, we can calculate that, right? So where the probability of class I is a proportion of data that has the response I. Make sense? Alright. So assuming independence, because that's why base theorem does, you have to assuming that there's independence in the predictors, right? So you can write the probability of class I given x as the product of the probability of x1 given class I and the product of all the other x's. Yeah? Make sense? And then probability of xj given class I can be calculated using a distribution that the predictors follow. So it can be Gaussian, multinomial, or Bernoulli, based on the data, right? So you use a Gaussian in normal classification, and assumes that the predictors follow a normal distribution. Use a multinomial when the predictors are discrete counts, that is text classification. So you have so you wanna count the how many times the word appears in the document. So use a multinomial, and then use a Bernoulli when all your predictors have 0, 1. So in this case, it's where 0, 1 means that this word appears in the document, 0 means it doesn't. It's when you use Bernoulli. Does it make sense? This will be arguments that you'll be changing in your function, in your naive Bayes function when you're coding. Yes?
If you live in Benoni, are you supposed to use Bernoulli?
No.
Okay, sorry.
Where's Bernoulli?
What?
If you live in Benoni, you have to use Bernoulli.
Just say where's Benoni?
Where's
I don't know.
No, sorry. Proceed.
Does everyone know when to use different functions? Because you're gonna be changing them as you do. So since we're doing classification, we're gonna be using Gaussian mostly. So there are advantages and disadvantages of naive Bayes. So the advantages is that it's fast and easy to implement, and when the independence assumption holds, it performs better compared to models using less training data. The disadvantage is that the independence assumption is very limited because in real life, it's almost impossible to find a set with independent predictors. Yes? Yes?
Sorry, you said the previous one that we should usually use Gaussian.
Yeah.
Is that normally what we use?
Yes, because it's the classification.
I will always use that for classification.
No,
Normalize.
in normal classification, but then if you're not going to test and you want to classify documents and all of that, You might end up using multinomial and Bernoulli, but then in most cases you're gonna use Gaussian. Questions?
Generally speaking, which one
It's not a matter of popularity, it's the data set that you have. So Gaussian, you use it when you're classifying observation. Multinomial is for when you're when the predictors are words in a document and the values are counts. So you wanna, so let's say you have a document as in a proper paper document, and then you wanna count how many there are dogs, right? And then your values are numbers. That's when you use multinomial. Bernoulli is when you now have 0 and 1, where 1 means there is a there in the document, there's a dog in the document, and all that. Make sense? Good. And then this is how the model looks like. So you have your training data, right? And then you pass it through an IU-based classifier, and then you use this maximum a posterior decision rule to do your classification. So when you pass your training data, your test set, you pass it through this by maximizing class I, by finding the class that maximizes the probability of class times the product of the entire predictors given class of that specific I. Yes? And then if your answer is class I is equal to 1, then it's a yes, and then if class I is equal to 0, then it's a no. So now let's go to the Jupyter notebook. So we do the same thing we've been doing. You type naive Bayes. And then remember we're performing classification, right? And then I say use the Gaussian model when you're doing classification. So you're gonna choose this one, Gaussian NB, which means Gaussian naive Bayes. So you instantiate your model, you fit your model, you make your predictions using your test set, and then you validate. And then your accuracy rate is 0.72. Right? And then, and then now let's go. Going back to the slides, right? Which one should I give you time to look at? This is the results, right? Should I give you time to look at it and then discuss which model to use? Which model best performs using those tables? I'm going to give you 10 minutes to discuss which model and why. 10 minutes using this table. Did anyone hear me? Sorry? Radio.
Should it change from degree to something?
Yeah, it uses gamma. It does not use degrees, it uses gamma.
Oh. So why was it so good when we didn't change the term degree? Or if you don't introduce this argument anymore, like gamma and
No, it's because already that default values. If you go back to the document, you see that default values. And then if you use RVF, right? RVF, it will mean that it ignores the degrees even if you have it. If that makes sense.
It will ignore that?
The degrees argument that you have in your model because it does not use it.
Oh, yeah. No, but then SVM is giving us that's the one that you read. Because then look at his false positive. And then, okay, there's a thing. It's false negative. But it's not that much more accurate. It's like just but now there's better sensitivity. So which one do you want my phone? Yeah. In general. Where's the miss rate? Where's the miss rate? It's false positive, it's false negative rate, the miss rate. It should be. Well, it should be because the answers would say if you had to change this to rate potential. I'm doing 40 and that's not much. So basically this rate is the same as false negative. One high specific. It's difficult to decide which one to choose. None of them. Because this one is so it's missing a lot of stuff. So rather keep it at M. Which one is better between K and M? Which one is better between K and M? Logistic is better. Logistic one. For this specific data set. But logistic regression is a form of classification. Just test everything until you find the isolated. Is that what you do, really? But you guys still are going to learn more, you know that. Nah, you don't have any. Our data is not enough for any machine. There's nothing to use. No, we'll wait for you to add more data. We have one rugby match video. We move from specific days. You can't tell me what to do the next day. But then we want actually. Yeah, you can't. Oh, no, but actually there's a lot of passes in one way, so if you can force it to predict the events using the one. Yeah, but we want to identify the event. We don't want to identify who's going to win.
From one match.
How many passes are in a single rugby match?
How many passes are in each game?
No, but that's what I want. If I have 200 passes and use 180 as my training, then use my other than 20 passes as my testing. If we can identify the pass, then it's done. That's what I want you to be able to identify the pass.
I like the game, some games more as well. Why
Yeah, the Man City reach. Man City there. Man City.
give me a rank.
On average 400 passes per game. On average 400 passes per game. On average 500 passes per game considering both teams passes. 500 passes per game. But anything that's the pass, is the pass.
So yeah, but again, that 55 in one day for one team.
But Rugby doesn't have this many passes.
It's moving more time. It's more like
So Rugby has more passes than
so it's constantly 10 minutes. It's probably around.
But honestly, when you do it like that, this thing makes me really boring as fuck. You just see the results as numbers. I want my output to be proper. Like I want to see it actually identified from the training data. I want to see it actually identified. I want to see which one it missed, which one it actually you get what I'm saying? I need to know this so that I don't know.
Are you guys done? Hello, let's go back to your slides. I'm gonna start with this.
Go down and get
And why? There's no right or wrong. Yes, why?
What do you believe?
He said it has the lowest false positive rate. That's why SEO is still. Okay? That's correct. Then he said SVM because it has the lowest false positive rate. What do you think?
Logistic regression.
Why?
On average, all the scores are competitive enough compared to all the other ones, and its false positive rate might be high, but then it's the SVM has a very high miss rate, so which means it's not classifying most of the data, even though there's a low. It's not recognizing most of the whatever data, because that's what the miss rate is, correct? I'm wrong again.
This one? Actually, let's start here. You guys. Which one? Which one? Sorry? This one?
There's a
Oh
group
my.
that was missed.
So,
Yeah, so what is your
because we stuck between the two, so which one? So,
What do you guys so far as they said SVM and they've said logistic. Which one? Which one?
In the box.
So we had a target to justification and SVM. However, we really so we chose SVM
Because
because it has no false
so you guys are going with SVM because it has the lowest false positive rate. Alright. Work with you guys, yeah.
Ten words in, 5 words out. The waste. You're getting 10 watt or maybe 5 volts. And your output you're getting 5 times 1, 5 watts.
I just
You
figured
lose
it
5 watts of power
Also need to think about the time of this.
just for you to charge something. Bro, I'll try it out after it's done streaming.
it's outside. Let's just wait until it comes 5 minutes.
I fulfill logistic regression.
I'm saying let's just give it 5 minutes there. See what happens. 5 minutes. You have to go now. Yeah.
Ciao guys. So far, logistic regression and SVM.
Sorry.
No one knows.
Thank you, man.
This machine learning
Yeah, guys, we're almost done.
Yeah, we're done. I think this is almost nice.
Remember when you said there's no right or wrong answer? I was not lying. So like, this is what I did, right? I circled all the high values for each metric. So logistic regression and SVM have the highest accuracy rate. And then logistic regression has and naive Bayes have the highest. They tie in terms of the sensitivity. And then you look at the SVM, it has the highest specificity and also the highest precision and also the lowest false positive. And then, sorry? Here. And then logistic regression naive Bayes has the lowest false negative rate. So personally, I would go with the naive Bayes. But there's no right or wrong answer. It's just about how you back it up. Back it up in terms of the data set that you're using, right? Remember, this is. Do you want to say something? Because of
just regression?
the data set that you're using, right? This is medical data. What you also always want to do is have to have the lowest miss rate, right? Because you don't want them to miss. Sorry.
Okay, yeah.
No, it's just the data set and the scenario in this case. I'm not saying it's the best one, but then if you're gonna go talk to a medical doctor, at least say that this is it has the lowest miss rate, because that's what he wants. He doesn't want to miss people, right? Because he wants to cure people. So I would go with SVM, but then also logistic regression has potential. So from here onwards, this is where you start. Maybe you can take logistic regression and SVM, and then start tuning them to see which one outperforms which one. Because this could be a case of the data set that you're using, or it could be the case of the parameters that you have used, right? So, yeah, there's no right or wrong answer. Right? That's it. Do you have any comments? Any questions?
Okay, guys, yes.
Are you done?
Right, so just a final thing to say, ne? On all of these workshops, what we've been doing is training a model and checking its accuracy, checking how it performs, etc. Once you're done training your model and you're happy about all of the validation parameters, you take that model and you now apply it. You actually, let's say you were classifying dogs and cats. You actually start feeding in some cats and dogs, and it tells you, oh, this is a dog, this is a dog, this is a cat, this is a dog. It's a combination of the two. Okay? So one person asked that, oh no, if machine learning is all about training stuff and then looking at the accuracies, that's pretty boring. What are you going to do with the accuracy when you're done? You take that model and you now apply it. So for those of you who are trying to classify text, you're going to train your models. Your model is going to perform well. It's going to have some numbers, some validation numbers. But then after that, you actually take it, and when you demo it, you're going to be showing it to some people. That you're not going to be showing that table. What you'll be showing is that, look, I can actually classify a cat or a dog. Look, I can actually tell you the sentiments of this particular paragraph. And the sentiments are positive or negative. Look, this complaint actually belongs to this class. And nobody intervened to actually specify which class it belongs to. So machine learning doesn't end here. This is just the training and the validation stage. When you're done, you go and apply your model. Okay? One day when you open your own business, that model is the model that will be running in, your customers, your clients that will be using your model to do text analysis or to do image recognition or whatever. Okay, so that's what machine learning is about. Okay, is there homework?
The one that they hate me, they love me now.
Yes, must go home.